ただいまより 5G、6G Special Day 2
Now we would like to begin the session 2 of Day 2 5G 6G Special Day, Evolution and Development of 5G and Local 5G, Advancing Industrial DX with 5G and Local 5G. I will be serving as an MC today. My name is Harumi Fujimura. Thank you. In this workshop, simultaneous interpretation service is in place. Please use the receivers distributed at the reception. Channel 1 is for Japanese, Channel 2 is for English. Now, at the outset, on behalf of the host of this workshop, I would like to invite Mr. Takehiro Nakamura, the project leader of XGMF Odaiba IX Core, for his opening remarks. Thank you for the kind introduction. My name is Nakamura from NTT DOCOMO, and as she kindly introduced, I am the project leader of XGMF Odaiba IX Core. So I would like to first explain what Odaiba IX Core is. So XGMF is a body promoting 5G and 6G. And Odaiba IX Core is specifically focused on promotion of milliwaves and local 5G. And in this session, in order to gain further momentum in promotion of local 5G, we decided to hold this session. I believe many people still believe and suspect that it is expensive, too complicated, not too successful, and it will end just with proof of concepts. After this, NTT East Japan and other presenters will be speaking, but I believe now we are facing a slightly different trend. So we have attendees today in the venue and online as well. And today I would like to convince you that local 5G is fully in place by introducing as many use cases as possible and future potential cases as well as existing solutions. That is the purpose of this session too. To that end, different from other sessions, we only have 5 to 6 minutes per person for their presentations, but we have 13 speakers who will be presenting. And we will have many use cases using local 5G, which will help you better understand what its possibility is. So now we'd like to jump into the program. The first speaker is Mr. Mashiyama from NTT East.
Thank
you for having me today. My name is Mashiyama from NTT East. So he just talked about 5G, and from over a decade ago, I have been engaged in the development of wireless services. It was originally called wireless LAN, and provision of services and implementation of services. I truly understand how they can take time. And from this year, well, we discuss often with customers about local 5G, and toward implementation, we have started to feel that customers beginning to have more concrete image as to how local 5G can be used. So first, I would like to talk about why local 5G is necessary. Different from 3G and 4G, 5G is using cellular technology in the industrial area, which is the first of its kind. And one of the challenges in the industrial area is a shortage of workforce. And advanced technologies and precious knowledge must be transferred to the next generation. Robotics and AI must be utilized to cope with these issues. And in recent years, For further promotion of AI, there have been many activities, and AI doesn't exist for AI, but it should be used for people working in the field, in the manufacturing sites, for example. And when we think about such AI for people, well, we are a company initially for broadband and optical network, but eventually we started to be more closely engaged with customers on their premises and help them address their daily challenges. And this has been difficult. High-speed broadband alone will not solve their issues. Communication is a tool that our customers can use, and on top of that, we need to digitally transform their work. And given such circumstances, LPWA, mobile, optical access, these are the pieces that can be used in digital transformation for customers. That is what we are aiming to do. And why local 5G is necessary is because it goes over a space. In the past, we needed to have an individual, a skilled individual on site. But when we have the network, we will be able to connect with skilled individuals elsewhere, and we can use the power of AI for cyber-physical collaboration. And the important point is to gather rich information from the site and consolidate such information and process it. In local 5G, we have ample uplink bandwidth, and it is low latency. And because of these features, local 5G will come into play. For 5 years, we have worked on this initiative, and we believe that there are use cases primarily in these 5 areas using local 5G. First is wide area wireless LAN. This is to cover large areas like airports and ports. That is the basis of this area. And expanding from wide area wireless LAN, going to the top left, we can do remote monitoring and seek support for remote work. And bottom left is remote control of construction machinery and robots. Top right is autonomous driving. We recently see autonomous driving buses, for example. We can check the real video to ensure safe driving. And bottom right is cybersecurity, which is one of the serious challenges. Because of our track record in the cellular technology world, we will be able to ensure safety and security. These 5 areas will be the key focus for implementing local 5G. Now, I would like to introduce examples from our lab, and we're connecting with them. We finally can see you. Thank you. So once again, this is local 5G Open Lab. We have visitors today, so we can't really zoom in. This is the exhibition, and the visitors can experience terminals connected to local 5G. And around it we are introducing the strengths of local 5G as well as use cases. And in some cases, you can experience what local 5G is realizing. And some use cases are related to IOWN. So we are introducing such combined integrated use cases too. This lab is updated on a regular basis, so we welcome first-time visitors. And if you already have, please come back for new updates. And that is all we can share from the lab. And now I would like to introduce the the specific use cases. Sekiyama-san, may I hand over to you? Yes, I would like to start explaining the specific examples. This includes a remote control technology. This is a use case related to reduction of cost and labor for the managers of construction sites. This is an example with Takenaka Corporation. This station covers a width of 90 meters, height of 140 meters, depth of 140 meters and height of 20 meters. It is capable of capturing the image of the on-site manager. There is a technical issue. The sound is not clear. Sato-san, I'm handing over to you. Yes, I would like to introduce our example with Nishimatsu Corporation. This is for a tunnel construction in mountainous areas. We are using local 5G and IOWN for the local communication. By using both, we can avoid latency in transmission of image. This enables remote tunnel construction with low latency and large capacity transmission. In this August, a local 5G environment was established in the field in Tochigi Prefecture. And we will be connecting this field and NTT Central Training Center with IOWN and APM going forward. From my side, I would like to introduce two use cases. This is with Nihon Kaisui. This is in Hyogo Prefecture. This Ako factory is located in Hyogo Prefecture. This is a large plant. And this has a metal shielding around it, so it causes electromagnetic failures. It can switch from Wi-Fi for stable operation as well. Large capacity communication is possible using local 5G. And we have a licensing scheme. The sound is not clear enough for translation. In this August, we have introduced local 5G. Next slide, please. This is a use case at Yumeshima Container Terminal. They already had a wireless network, but they were facing some challenges. Cranes are remotely operated. High-speed communication was required. Highly reliable communication was needed. Movement of cranes are monitored on a real-time basis. Trailers, entry and container check. Normally, when there is a problem with the container, the person in charge is called, and he or she has to go to the site, spending long time. But using this local 5G network, image or video is shared among the related persons. This has contributed to reducing the time required for completing the task. Cost reduction is expected. That is all for the use cases, and next slide is on the smart factory and the logistics lab. Sakata-san, please. Thank you. This is Local 5G Open Lab, Smart Factory, and Logistics. Using Local 5G, we are exhibiting an actual flow from the arrival of goods to shipment. Have a wish to introduce Local 5G to their manufacturing sites, but they definitely need a test bed. That is why we have prepared this kind of lab. Out of the lab, this is connected to the local 5G base station. It smoothly hands over to the outdoor base station, which enables smooth operation. So that was the AGV operated through local 5G. Now, Mashiyama-san, back to you. I apologize for the poor sound quality. So I can fully understand this difficulty with Wi-Fi. Without stable network, wireless communication can be very stressful, and that is exactly what we want to solve using local 5G. And last but not least, local 5G is now starting to be used by customers as a norm, I believe. And in various industrial areas, we would like to utilize local 5G to meet the needs for data and network. That's it for me. Thank you very much. Thank you, Mr. Mashiyama.
Right, so we did experience some instability using Wi-Fi. That shows that we do really need the local 5G. Now, I'd like to invite the next speaker, who is Mr. Sakamoto from KDDI Engineering.
Hi, 皆さん、こんにちは。
Good afternoon.
KDDI Engineering の坂本と
I am Sakamoto from KDDI Engineering. Today, I'd like to talk about the local 5G, which support future dam construction sites. First, briefly, I'd like to introduce our company. KDDI Engineering is a 100% subsidiary of KDDI. Major business is the construction and maintenance of the communication facility. Our strength is that we provide designing, construction, monitoring, and maintenance for the network. We provide end-to-end service as a professional group. Now, turning to the strength of the local 5G of the KDDI Engineering. We have a rich experience of developing base stations, and also we have a technology capability with which we have developed the highest quality network. Leveraging those track record and technology, we can provide flexible network. Specifically, by working with the multi-vendor approach, we can provide a selection of equipment which is most suitable for the needs of the customer. And also, we have our own lab, so we can conduct a quality verification before the supply. And also, we provide a 24/7 monitoring and also a quick on-site maintenance to ensure high-quality 5G communication in a stable manner. And our strength is exactly that we can provide what I just mentioned in an end-to-end manner with our local 5G. Now I'd like to talk about our 3 example cases of the implementation of 5G. At the very left, this is example of the implementation at dam construction site. So the site of the construction are with complicated terrain, and we developed a scheme where we have a wireless communication with a low latency and massive connection. In the center is another example, which is for the indoor facility allowing free viewpoint sport viewing. This is the environment where there are many audience in presence, and we enabled high-speed, high-capacity wireless communication, and we provided a 360-degree free viewpoint sport viewing. At the very right is a third example, which is a robotic facility inspection at plants. We developed a wireless network, giving consideration to complicated facility structure, enabling a high-speed, high-capacity communication. I'd like to go into detail for the dam construction site example. This is a Shin-Maruyama Dam, which is in Gifu Prefecture, which Obayashi Corporation is working on. At this construction site, in a wide range with a height of 160 meters and a width of 537 meters, we provided a network of wireless communication. Utilizing this network, a crane automatic operation was made possible. And in developing local 5G area, we conducted a network area giving consideration to the dam construction plan, and we deployed antenna in a limited spaces so that they don't hinder works. And I myself visit this site many times to enable low latency massive connection network. Working with Obayashi Corporation, we developed local 5G environment in the very harsh environment, enabling the automatic operation of the heavy machines. So this was the example of the labor-saving solution at construction site. So next speaker from the Obayashi Corporation will give a more detailed explanation. So I'll conclude my part of the presentation. Thank you very much. Thank you very much, Sakamoto-san. As introduced, I'd like to now invite Nishi-san from Obayashi Corporation.
Thank you
very much for the introduction. I am Nishi from the Obayashi Corporation. Today, I'd like to share with you the example of the Shin-Maruyama Dam construction site where local 5G was very effective. So this is the overview of our company. Obayashi Corporation works on civil engineering and construction site both in and outside of Japan. And in relation to the Osaka Kansai Expo, we were involved in the Grand Ring construction. And January last year, there was a earthquake in Noto Peninsula, and we were also involved in the recovery project while utilizing a remote control technology. We are 130 years old company, and throughout the history, environment surrounding construction industry have kept changing, and we are always conducting business while sensing the change in the environment. I'd like to now talk about the challenges faced by construction industry. As shown in the graph, in past 25 years, there's a reduction of the skilled labor in the industry by 30%, and we anticipate this trend to continue. However, there are various infrastructure which are aging after 50 years since they were built. So we need to be addressing this issue as an industry. To do this with limited number of people, improving productivity and developing labor-saving technology are essential. Therefore, at Obayashi Corporation, we are aiming at R&D so that the heavy machine can be operated and manned. At the construction site, concrete pouring or the aggregate production needed for concrete pouring will be produced on site. Aggregates are like a sand or rocks and such. At the dam construction site, we have a autonomous concrete pouring system under which the conventional construction machine are to be operated automatically, and this is a challenge to save labor. The autonomous concrete pouring system development requires autonomous driving of multiple and different types of the equipment, and also remote control are needed, and they come with many challenges. Therefore, we decided to adopt local 5G as a communication infrastructure which allow low latency, high capacity communication. But we alone, as a construction company, do not have a know-how or insights needed for development and maintenance of local 5G. So we decided to work with KDDI engineering, from which we had a previous speaker. So the engineering is to be worked. Construction-related engineering will be worked on by us, and the communication engineering are to be done by KDDI. So this is the on-site station being shown. And about the sites, if you have a question, I'd like to take questions separately. So I'd like to show you a video here. So this is the Maruyama Dam in Gifu Prefecture. This is alongside the Kisogawa, which is with the fifth largest area. And this is a very large project to enhance the function of the dam. And December 2023, we established the automatic automation of the 10 of the machines. This is the loading of the sand with a backhoe, and this is the transport of the mud with the truck, and then leveling and allowed and other tasks are being able to automate it in a stable manner. What you are seeing now is the bulldozer. It may be difficult for you to see, but this is fully manned. And this roller is also marked without a person operating, and the multiple vehicles were operated in a completely stress-free manner. And this is a remote control. Remote control was done 300 kilometers away from the construction site from our headquarters. We were able to confirm that this happens. And the latency was just 0.2 milliseconds. So the operator regarded the performance very good. And also camera footage was also being able to transmit it in real time. So we were able to confirm that there is a positive side effect in the area of safety. And we confirmed that local 5G is a very useful and effective communication infrastructure for automotive autonomous operation of those vehicles. And we'd like to further establish those technology. Thank you very much for giving this opportunity. Thank you.
Mr. Nishi, thank you very much. Now, next presentation is from NS Solutions Corporation, or NSSOL, and the speaker is Mr. Iida. And also, the next, following after Mr. Iida, there will be presentation by Mr. Watanabe from Kyushu Power. Hello, everyone. My name is Iida. I'm from NSSOL, or NS Solutions. Today, I would like to talk about our smart factory projects and also local 5G introduction cases. Now, first of all, this is our company in brief presentations. So we are a IT subsidiary within the Nippon Steel. And we have about 8,000 people as our employees. Now, first, let me talk about our smart factory division. Using 5G and other network is used to collect data in our platform, and also we do use that platform for safety monitoring and also quality improvement and also predictive maintenance, traceability, and digital twins. All of these activities are to enhance the site or the field DX. Now, our strength is that using the steel, Nippon Steel's field as the proving ground, kind of, we are able to solve the business issues and also are able to introduce DX solutions in IT and OT areas. So far, we have covered the solutions for power, utilities, energy, process manufacturing, assembly, and also industrial equipment manufacturing, port, harbor, and communications. So now let me talk about specific local 5G project. Now, this is the site of the Muran steel mill, and we were the first one at that time to achieve 63 watt, which is the largest level within Japan under the license of local 5G, covering very wide area. Now, this is another example here in Tomato Atsumichi thermal power plant of Hokkaido Power, and we introduced a local 5G system for them to enhance their their operation efficiency. This particular, there's a particularly similar project run by Kyushu Power, which will be delivered in the following presentation. Another example is this one. This is within the tunnel of construction site by Takenaka. And we realized 360 degrees free perspective remote testing inspections. And although the user is remotely located, the inspector could look at the site in detail as if that person was there. And this is another case of allowing the remote operation of ceiling suspended crane at Toyota Steel Center. And the high precision image was transmitted with minimum delay or the latency using 5G network. This is another case. We introduced the local 5G network introduced in the automation lab in Omuron. They established the environment for the POC, and this result has contributed to the acceleration of this initiative at Omron to introduce local 5G in the future. This is another example. This is with the Subaru, and this is their proving ground in Hokkaido. And even though the vehicles were moving very fast, they could still use local 5G to track the vehicle conditions. And using these efforts, we are promoting more and more field DX as their DX partner to solve the problems and issues in the actual sites. Thank you very much. Mr. Iida, thank you very much. So next, let's go to Kyushu Power. Mr. Watanabe from Kyushu Power will present their effort related to local 5G network. Thank you very much for introduction. My name is Makoto Watanabe from Kyushu Power. Now, in our company, we are using 5G or local 5G network for the purpose of the smart maintenance in power plants. I would like to skip my self-introduction, but let me just explain about our team. Now, in August this year, I started to belong to the Communication Solution Department for internal support. And in that team, we provide the local 5G network introduction for plants and power plants. And also we are working on solutions to propel the DX for internal purpose. Now, let me talk about the local 5G network. In Kyushu Power, we are introducing local 5G network in thermal power plants to support smart maintenance. The first thing we did was to have iPhone directly connected to the network, and also we are considering the use of wearable terminals and AI analysis in stepwise manners. And also we plan to roll out these solutions from not only the thermal power plants, and also to nuclear power plants. This is the local 5G network schematic illustration that we have introduced. Outside of the buildings, we are using a local 5G, and indoor environment uses Wi-Fi. It is a hybrid solution, therefore. And also for the local 5G, Nite Solutions as high output radio units are used to cover wide area, and also by using their high output units, we were able to reduce the number of the units we introduced. And also there are many obstructed environment within the indoor space, so for that we are using Wi-Fi. So in this kind of environment, such as power plant, we do believe that this hybrid approach is most appropriate. Next, let me show you what we have done so far. Now, already iPhones and local 5G network can be connected with each other directly. In 2024, we delivered the company iPhones to every employee. And initially, however, it was not possible to connect to the local 5G directly from the iPhone. So initially, we provided the 5G routers to the users so that they could connect to the network through Wi-Fi. But because this year, the iOS 17 is now can support local 5G directly, and also thanks to other core equipment upgrade, we are now allowing employees directly connect from their iPhones to the local 5G. We believe that this is probably the first use case as such among all the utility companies in Japan. Now here's our outlook. This map shows the network that we use for transmission and distribution of the power, and we have Matsura Thermal Power Plant in Nagasaki was the first one we introduced 5G, and we are now going to expand the rollout of the local 5G in remaining 6 other thermal power plants. Today, we have 2 nuclear power plants, and those 2 sites also will receive 5 local 5Gs in the future. So we are expanding the rollout, but the terminal accommodation is taking time. So we are coordinating with the power plant departments who are responsible for the terminal technology to expand the usage of the 5G, local 5G network. Now that we are given this opportunity to be here, I would like to also learn from all the other people. Thank you very much for your attention.
Thank you, Mr. Watanabe. Effectiveness in power plants. Thank you for explaining a lot about it. Next presenter is also from the energy field, from Hiroshima Gas. I would like to invite Mr. Kohno. Mr. Kohno, the floor is yours. Thank you for the introduction. My name is Kohno from Hiroshima Gas. Today, I'll be presenting a case study about initiatives toward realizing smart security using autonomous robots and other technologies via local 5G networks. And I'm sorry about the lengthy title. This is the outline of Hiroshima Gas. The red circle at the bottom left of the map is the Hatsukaichi plant. I will come back to the details later, but this is the site where we are implementing the solution. This is today's agenda. First is about the expansion of the local 5G network itself, which is the addition of new base stations. Specifically, in addition to the 3 stations constructed during the MIC's development demonstration phase in FY 2021, we added a 4th base station, which covers the area behind the round cylindrical storage tank, transmitting signals from west to east. And this covers the travel route of the autonomous robots that communicates with this local 5G network. And next is regarding the deployment of Wi-Fi networks operating under local 5G. We've proceeded in stages and installed a total of 18 access points. This enables area-wide supplementary coverage, which we utilize for human-type communication. And regarding tools used for human communications, specifically, this involves connecting smartphones, tablets, and smart glasses we introduced on a trial basis to local 5G via Wi-Fi. The most significant effect of building these environments is that we were able to establish a communication network continuously as a BCP countermeasure. There is a small picture, but previously we were using PHS to build an on-site network. Our company would play a role in supporting social infrastructure where business must continue even when communication carrier networks are restricted during disasters. Therefore, being able to utilize local 5G to replace the PHS network was extremely meaningful. This is the AGV, unmanned transportation vehicle. So AGVs meeting criteria such as outdoor rated, waterproof, and capable of autonomous navigation and allowing for customization were actually quite limited in choice. But this is manufactured by Aichi Kikai Techno Systems. And based on this model, we customized it by adding various sensors, control PC, and local 5G router. And please watch this video, which is introducing the AGV in motion. So it is on patrol inspection duties, and it is detecting gas leakage. This is a simulated leakage, but from the office, we get to see this on a real-time basis, and at the same time, it is capable of measuring the temperature, telling us that everything is right. and it returns to the base point. And normally, this AGV travels in the evening where there are fewer people on site. While focusing on transitioning what was achieved in Step 1 into full-scale operation, we believe that pursuing further improvements in Step 2 and beyond can also contribute to realizing smart security. Regarding future plans, we have other plans as well, so we envision expanding to other locations, and if possible, we would like to package it effectively for external sales as a solution. That concludes my introduction of the local 5G implementation case study at Hiroshima Gas. Thank you for your attention. Thank you, Mr. Kohno. So, Mr. Kohno, since we have extra time, I'd like to ask a question. So you said you're using both Wi-Fi and local 5G. How do you use them differently? Well, in local 5G, we are ensuring that there will be no issue even if the connection is interrupted. But we have an LNG tanks on site, so we are using Wi-Fi to supplement and complement the local 5G network for uninterruptible operation. Thank you, Mr. Kohno. Now we are moving on to a presentation from Mr. Kinno of NTT DOCOMO Business. Hello, everyone. I am Kinno of NTT DOCOMO Business. In the presentation so far, from demonstration to implementation was the theme, and I'm sure that you are now getting the sense of reality for these solutions. And today, I'd like to focus on the changes on the infrastructure side for commercialization. So I am now doing local 5G business and service planning. I was originally working in NTT DOCOMO, working on radio planning and development of mobile networks. And now I am handling B2B 5G, local 5G business. And this is the situation perceived by NTT DOCOMO today. We have a feeling that there is more commercial introduction of local 5G, and we believe it now accounts for about 22%. Right side is the market analysis. In 2020, this is how it looked like. And compared to 2020, although the pace may be slower, we have a feeling that it is ramping up. And for further commercialization, I believe we have clear challenges. There are three of them. One is lower cost. Second is redundancy for uninterruptible network. And third is a full and fast maintenance. I believe these are the three barriers for commercialization. On the 25th of March, we released local 5G service Type D. The characteristics of this service is we are utilizing the carrier equipment and structure of NTT DOCOMO, and by sharing them, we can achieve lower cost and redundancy and the maintenance ability. We will be able to offer instant maintenance even on holidays. Commercial service can be achieved at a relatively affordable cost. This is the structure utilizing DOCOMO's facility. Below the bottom half is the structure for Type D. So we have the base stations of DOCOMO. In the middle, there's UPF and core units. And on the left-hand side, we have the customer's premise or building. They only have RUs and antennas. So we are using optical network. And there is no need for installing server racks. It's very simple. And even if there's a failure, DOCOMO staff can run to the site for a quick maintenance. So bottom left and top right, we have these blocks. Of vertical is expenses and horizontal is redundancy and maintainability. So if you place more importance on a stable availability, you would go for the one at the top right. And if it's only for a POC, you would go for a bottom left. And as a service to fill the gap between these two, we decided to release this Type D product. This is the expected scene of usage. As discussed earlier, in a crowded situation with public general users, you still need to do abnormality detection or communication for operational purposes. In many cases, we're receiving inquiries for introducing this network at stations. And also in manufacturing sites, AGV is used connected to local 5G. In the aspect of local 5G stable connection, we have a combination with slicing in our implementation. The richest is the local 5G. So we will be using different networks for different purposes, even on the same premise. This is for broadcasting and remote production. There is an increasing need for use in stadiums, which is a crowded environment. The network availability is quite tight in this environment, so we believe that there will be increasing demand for large capacity transmission. So we have started to work on implementation in this environment. So that's it for my presentation. Thank you. Thank you, Mr. Kinno.
Now I'd like to invite a next speaker. The subsequent speakers are from the transportation area. First, I'd like to invite Mr. Oyama from Shitoko Metropolitan Expressway. Thank you very much for the introduction. I'm Oyama from Metropolitan Expressway. I'd like to discuss the communication resilience improvement and on-site DX using local 5G. First of all, I'd like to talk about one of our major missions, which is to prepare for the Metropolitan earthquake. We have a road clearing plan in case of Metropolitan earthquake, which is to secure a road to transport materials or the goods in the station of disaster. And under this plan, we are to open up a road to secure the transportation road for emergency vehicle or for the supply of goods. But to do those work quickly, first we have to gain a stational awareness on site. That is the most important thing to be done. Now, why do we need the next generation communication infrastructure? This is to address challenges both in a disaster station and normal time. First, in a disaster station, in order to secure emergency transportation road, we need to quickly grasp the on-site situation. And also, on the normal time, we have the aging of the infrastructure, which is very serious. So the damage on the road needs to be detected quickly and responded in a very efficient manner. And also, there is a heavy traffic load, so they need to be efficiently controlled through remote control. And in order to address those challenges, we are to secure we want to secure a communication infrastructure that does not get disrupted even in the disaster situation, and we also like to use such network for advancing our operation and improve efficiency. Now, the road are in different shapes with a straight section, and also we have a curved section. By implementing a different equipment and technology which is suitable to a different section, we are to develop a network by utilizing both directional antenna and a distributive system. And we have started working on some specific section already. Now I'd like to talk about the concrete use case. Once we develop local 5G, what are we going to use them for? For example, we will be able to go wireless with regards to the equipment alongside the roads so that we can lower the maintenance costs. And also, by utilizing high-speed data transmission, we will be able to utilize a 3D data. We can even handle a high-capacity data, so we like to use those data insights for the advancement of the inspection or maintenance. And also, we believe that those local 5G can be used for information sharing in an emergency situation. In order to realize those use cases, we're now jointly working on research project with the University of Tokyo. We can see the 4th Shinjuku line, and we have a Yoyogi parking area, which is on the photo. And we have established a local 5G base station to do the research there. For example, we are working on establishing a network design approach for our expressway, which is with a complicated condition. And also, we are working on handover automatic control research. And also, we are working on location information technology within tunnel. We are working on them one by one. We will continue our effort for utilization of local 5G in our environment. That concludes my presentation. Thank you very much. Thank you very much, Oyama-san. We still have just a minute, so I'd like to ask you a question. Local 5G does not need a license when they are to be applied to a specific area. But when the local 5G is used along the road, did you have any challenge? Well, of course, there is within the major principle that the operation is to be done within our own premise, but we made the application to the authority with the usage for the usage of using this on the premise. So the restriction is that we should not have radio wave leakage outside of the road infrastructure. Well, thank you very much. That was insightful. Now, next, a speaker from the transportation area. Next is related to railway. I'd like to invite a speaker from Railway Technical Research Institute. Speaker is Nakamura-san. Thank you very much for the introduction. I am Nakamura from Railway Technical Research Institute. I'd like to talk about the information transmission test for the application used for railroad services utilizing 5G and L5G in the underway metro field. We are working together with Tokyo Metro, Hitachi, Mitsubishi Electric, and NTT DOCOMO in our effort. First of all, I'd like to share with you the issues we're facing in railway communication systems. So currently, when it comes to our wireless communication system, what we see is that we have multiple independent wireless network system in one location. For example, in one rail car, when there are multiple apps, we use a different wireless communication system for each app. Also, at this moment, we have those wireless networks are our own dedicated network wireless system, especially when it comes to operation of the railway. So that means that we have high cost for implementation and management and maintenance of such network. So given the station, we wanted to integrate those multiple networks, and also we want to utilize the new system so that we can meet the latest specifications. So those are the challenges that we're facing. And to address that, we conducted a verification study of the applicability of the public and local 5G to the railway app information transformation. So this is the specific of our test. So tested section is the area going across 3 stations of the Shinotsuka, Myogadani, and Korakuen. So there are tunnel section and non-tunnel sections. And the non-tunnel section, we selected this area so that we can test both a tunnel section and non-tunnel section. And as shown on the left bottom, there is a section where the public LTE can be used, and also there's another section where public 5G can be used. And we applied a local 5G with 2 base stations and 3 antennas. Currently, the Union of UIC is taking lead in developing a specification, and referring to that, we prepared a communication platform so that multiple apps can be used simultaneously, and refer to that. And we conducted a test to see if the app can be used without a problem using dedicated wireless, public 5G, and local 5G. I'm sorry that I've kept using many jargon, but our idea was to use the app related to CBTC, ATL, CBM, CCTV, and wireless. And that was the scope of our verification test. And this slide shows the example of the outcome of the test, starting from the left-hand side. The yellow plots are LTE's reception power, and the green plots are public 5G reception power, and red and blue are the local 5G reception power. And the local 5G is not being able to cover the entire section, but we came up with a configuration where we can use the hybrid configuration between public and local 5G. And with regards to CBTC system, we were able to have a transmission of the wave with a high loss rate. And jitter was from 124 minimum, but from the on the ground to the car, there was no delay. And also we tested the transmission of the image data, and but the delay was less than 30 milliseconds with local 5G. So the stability was higher in terms with regards to local 5G. And with regards to autonomous operation, although we are not really conducting autonomous operation in reality, but we enjoyed the low latency with regards to local 5G, lower than the case of public network. And with regards to the reception interval, again, we saw higher stability in the local 5G. And in terms of the one-way delay from the train car to the underground, the uplink is important for our operation because the onboard camera image is expected to be sent. And then once again, the local 5G showed a higher performance compared to public 5G. So we can conclude that the local 5G gives us a lower variance and reception variance and a smaller delay. So the insight is that we can renew communication infrastructure using hybrid approach. Now, lastly, our expectation for the future and challenges that we need to overcome. Due to the result of the field test, we were able to hold on to the hope that we will be able to use the hybrid approach. But the time or duration of the test was rather limited, so we need to test for the longer period. And also, the test was conducted at nighttime, and so we need a test also in daytime. In that case, we expect the higher congestion, potentially giving a higher advantage to the local 5G. And if we are to move to local 5G, under current regulation, we need to deal with the licensing issue. Underground and during the tunnel section, we don't have to worry too much about the licensing, but on the ground, we may have to consider the relation issue, because as was mentioned by the Metropolitan Expressway earlier, we need to be mindful of the potential leakage of the radio wave. And so if the regulation can be amended, we will be able to use the local 5G, leading to new application to be used. And under the hybrid approach, we have to be mindful that the public 5G can't be used in the tunnel and also in the hilly and mountainous area. Probably in the case of railway, we won't be able to cover entire railway with the public 5G, so we have high expectation for local 5G. That was my brief report of the outcome of our demonstration test. Thank you very much, Nakamura-san.
So let's go to the next presentation. Mr. Nakamura from the Regional BWA Promotion Association. Mr. Nakamura is also from Hankyu Railway Systems, actually. I have only 6 minutes, so let me cover the Regional BWA Promotion Association. And because we have only 5-6 minutes, so it's really limited in terms of the volume of the information, but let me explain. So specifically, I would like to talk about how users are using, or the operators are using, or the businesses are using local 5G. Maybe you don't know the term regional BWA. This is the like in the case of carrier or the MNO, small mobile telecommunication systems can be used by small community or small regions, like in the size of the municipalities. And already in Japan, over 150 regions or the local locations have this service. Now, normally in BWA, regional BWA, 2.5 gigahertz band is used for 4G LTE services, and but now 5G is coming, and therefore there's more attention on local 5G. So today I would like to focus on some regions which are using. We heard from the highway systems, and so I would like to talk about 2 cases which have to also to do, one of them to do with transportation. One is Hanshin Cable Engineering, and the other one is run by Akita Cable TV. There are 2 different locations within Japan. First, this is in Akita Prefecture in Kamiyani village. And since 2019, this community is running autonomous driving transportation service vehicle for citizens. And basically, this is like a cart you would have in golf course. This is electromagnetic guide cart. And there is one person who is driving. Now they have 4 routes, but now they want to expand this service because there's increasing number of the elderly citizens, and also there is always limited number of the people who can operate this. So eventually they want to enhance the autonomous driving to level 4. To do this, the remote monitoring will be necessary, and that is why to support this committee, they started with the LTE, which is provided by a carrier, local carrier, to see how remote monitoring can be done. But some of the areas are not served well in terms of the signal. So that is why they are using local 5Gs for those underserved areas in terms of the signals. And they did it as part of the MIC-supported POC project in 2024, and it was very successful. They still have some issues, but they were overall successful. And they were doing sub-level 4 autonomous driving, but now they're targeting that autonomous driving of level 4 so that they can provide transportation services for the citizens using local 5G. So this is one effort of using local 5G in a local community. The other one, this is the very similar to the other examples given by the transportation services company earlier. This is in Hyogo Prefecture, Nishinomiya City, provided by Hanshin Cable Engineering. And they're trying to use the local 5G for train systems. And as in the case of highway system, their sites are long strip of land, and they want to use the network to cover all of those railway lines. But actually, because the lands are really long strips of land, a lot of radio waves are leaked. And of course, they want to keep it within the site as much as possible. So they are also, they're having a lot of discussion with the MIC, but of course, it is not very difficult. It is not very easy to stop leaking of the way signals. So what they are doing in the discussion with MIC is, if the signals are leaking out of the sites, maybe that could be taken, but they're used for the betterment of the community. So that is why they're talking with Nishinomiya City. You see the bridge and also the drone. So there is a bridge just next to the railway system in crossing over the Mukogawa River, and this bridge needs to be maintained by the local community. And so the idea is to use the drone to monitor for the purpose of the inspection of this bridge using the leaked signal. And so hopefully next fiscal year, they will be able to have the regulatory framework so that they can use this leaked signal for the betterment of the community. And we do believe, so through these examples, I do hope that you can get some inspiration for the improvement or the take-up of the local 5G by local communities. Thank you. Mr. Nakamura, thank you very much. So we heard presentation from transportation systems using local 5G. So I'm sure you found many information inspiring for you. So next one is the Ms. Namatame from Nokia Solutions and Network. Sorry, Nokia Solutions and Network. Good afternoon, everyone. I'm from Nokia. My name is Namatame, and I belong to Enterprise Campus Edge Solutions in Cloud and Network Service Divisions. And today, I would like to take a slightly different perspective. As a global vendor, how we are looking at the global private network. That is something that I would like to talk about. So you see here, the track record of how we help build a private wireless network for over 920 companies. You see on the global map, the blue areas are the places where we have helped install the private wireless network. In the following slides, I will talk about the fact that we have helped people in North America, Australia, America, South, Middle East area, and also Europe, and many other regions. And recent examples include like port harbors in UK, for example. And looking at the same situation from different angle is this one. So this is a statistics about the customers of ours for the private wireless. In terms of the industry, the biggest portion is the smart city, public sector. This is green portion. And the next one is darker green utility or energy. And the blue one is a third, which is transportation, followed by the yellow one, which is the manufacturing. Recently, the number of the makers are increasing, but port, harbor, and airports are increasing, also using self-operated private network. And they are to some extent, they are using such wireless networks to enhance their competitiveness in the global market. In terms of the regions, the largest installment is Europe, followed by North America and Asia Pacific, and then South and Middle East, followed by Middle East and Africa. The private wireless frequencies are defined by countries. That is one of the key things that we have to consider. In Japan, as you probably know, the country has been adopting, and the local 5G have laid out regionally framework. And so for us too, the local 5G growth is faster in Japan than in some other regions of the countries. In terms of technology adopted, 4G or 5G or the combination, the biggest portion is still 4G, and also 4G plus 5G is combined with 4G alone would account for 80%. And there's only 90% who is using 5G alone. That means there's a huge room for growth. Later, I would like to talk about some specific cases where use cases or the terminals used in 5G standalone network are the areas that we have to work on further. In terms of the channel used, direct and indirect indicated, of course, indirect is much greater because the enterprise market is huge. So it's not a market where one company alone can support the client, and also clients are varied in terms of their needs and pains, and we really have to understand their problems clearly, and that is exactly why we have to partner with the other people, and that is why we have most of the business coming from indirect channel. Let me share with you one example. This is in Finland, which there is the test mine called Kalilo, which is the deepest mine in Europe, and which is deeper than 1,000 meters. And they started to invest in private 5G network to use applications to generate profits, and they want to present the solution that will be leading the world in this mining industry. And they look at the remote monitoring and remote operation of the vehicles, and also safety monitoring, and also staff's remote trainings, all done by using local 5G. And today, they are now using the Nokia 5G 360 degrees camera that can be used with this kind of network, and using this, the bottom of the mining site can be monitored by using this camera and private 5G. What this means is, in mines, the deep sites are inherently dangerous, and so as much as possible, you want to keep people away from them. And so such harsh and rugged environments do exist in mining industry. So by using private 5G networking, those dangerous sites can ease the burden on the workers. And now that we have amenable terminals like 5G 360 degrees cameras, you are seeing increasing opportunities for the use of private 5G network in mining industry. That's all from me. Thank you. Ms. Namatame, thank you very much.
Next, I would like to invite Mr. Kenmotsu from Kyocera Mirai Envision.
Thank
you for attending CTEC 2025. My name is Kenmotsu of Kyocera Mirai Envision. Today, I would like to present under the title of The New World of Industrial DX Unlocked by 5G and Local 5G Expanding Application Through Device Evolution. Currently, developing an area for local 5G is no longer difficult. 5G and local 5G are more utilized in industries, and the key here is terminals. In this presentation, I would like to talk about how the evolution of terminals or device is expanding applications of 5G and local 5G. This is going to be a quick presentation, so I hope you can also check the archive video. Now, I would like to introduce some of the key use cases. First is video transmission. This is a mobile broadcast device, LU800 by Sanshin Electronics. This is a professional model for broadcasting. In the World Athletics competition, this was used. It can accommodate up to 8 SIM cards, and using the bonding technology to aggregate multiple cellular lines, it enables a high-quality image transmission and high-speed file transfer, even in a stable communication environment. Next is IR800B by IDY. This is a use case in the railway industry. This is the 5G Edge Gateway. It conforms with 3GPP Release 16 standards, and it has a processor that supports 10 gigabit per second speed. It has the highest speed as an industrial 5G router. Temperature, vibration, shock, noise resistance are supported just like IR730B, enabling high speed and stable communication. Next is an example of usage in a harsh environment. IGW5111 of Sumitomo Electric supports 5G millimeter waves, and it conforms with IP66 in terms of dust and waterproof performance. It can also conduct execution of application, which is edge processing, and it has AI GPU, and it is suitable for outdoor usage. Next is a Kyocera Digno tablet. It has resistance to fall, and it is waterproof and dustproof. It is chemical resistant as well. This is a corporate use 5G tablet with a function to read NFC. Next is DuraForce EX of Kyocera. It satisfies the MIL standards and the proprietary durability test, including 31 items. It is resistant to fall onto a concrete surface from 1.8 meters height. DuraForce and Digno tablet of Kyocera are widely used in construction sites and logistics warehouse. Next is Alps Alpine's local 5G terminal unit. GNSS positioning support is provided, and this is a suitable solution for mobile communication. This is often equipped to vehicles. Next is AMIT VHG 87B0G018. It also satisfies the MIL standards and EN 50155 standards. This is used for robots and buses. It has automotive design. It is often used for unmanned autonomous driving of buses in demonstrations. Next is Fujisoft Plus F FS050W. This is the first model in Japan to support eSIM as a SIM lock-free Wi-Fi router. And the price is around 30,000 yen, which is very affordable. It also supports dual SIM. In cases where you need a large number of terminals, this is the best solution. And finally, as a new product information, currently we have the local 5G system OmniPod, and we will be releasing the OmniPod 2.0 in the second half of 2026. This will be supporting iPhone. The details will be announced in a separate occasion. And through today's introduction, I hope that I was able to convey a local 5G application is really expanded as an application by terminals evolution spanning over different industries. We will continue to pursue industrial DX. Thank you for your attention. Thank you, Mr. Kenmotsu. Next is the last speaker. So, from Nakawo Lab of Graduate School of Engineering, the University of Tokyo, Mr. Takezawa. Hello, everyone. I am Takezawa of Nakawo Lab, the Graduate School of Engineering, the University of Tokyo. Today, I would like to talk about local 5G social implementation created together with users. Based on the academic field of information communication and information science, we are researching creation of next-generation cyber infrastructure supporting future society. We are a board member of AI Alliance, and we are engaged in the advanced research on the next generation infrastructure from the perspective of a social necessity. And we have been carrying out field demonstrations. We have been involved in many international collaboration projects and industry, academia, and government collaboration projects, including with those of you who are here today. I was listening to the presentations, but through these projects, we are working on social implementation. So, as one of the outcomes of social implementation, we have developed a small integrated 5G base station which can easily deploy local 5G. This is called Hypernova. This is expressing our expectation for exponential penetration of local 5G in the future. So local 5G is affordable, quick, and high performance. Well, it may be rude to call this cheap, but we place emphasis on its size, which is very small, and it supports TDD2 and 3. Some presentations talked about the importance of uplink, and it has over 700 megabps uplink, and it can have a concurrent connection of over 500 units. We will be updating to adapt to technological evolution. So we are exploring use cases of next-generation communication led by users. So first, we need to have a platform where the user can take an initiative to solve their issues. And a local 5G must be the suitable solution for solving these challenges. And the second point is a platform or infrastructure which is resilient and secure. And a customization for standardization also need to be pursued. So use of the sea and the upper airspace, these are being institutionalized, and also the licensing scheme is in place. It is often perceived as complicated, but by having licenses, it can also be used during disaster response. Now, I'd like to talk about specific examples. Dam construction example was discussed earlier, but this is something we are also working on. So this is a site with over 100 meters width and depth. So this is a critical infrastructure. And we are also doing demonstration in Mount Fuji. It is an active volcano, so it can erupt at any time. In preparation for a potential eruption, we are conducting demonstration to make the infrastructure redundant using self-run network or local network, and to utilize digital system, which is phase-free. So this is starting from October 20th. This is a promotion of DX at municipality offices. We are working with Avataring, the company, and I hope you can check the details at your leisure. So in using AI, uploading is critical in order to collect information from the field. So that is behind this huge expectation for local 5G. So technology will evolve from 5G to 6G globally. At the same time, we need to make innovation and evolve using local 5G. And in using AI, we have been implementing local 5G in various projects. In our Hongo campus, we are developing a campus testbed. This shall be a place for co-creation with all of you, so that we can feedback ways to realize social implementation. I really look forward to working with you. Thank you, Mr. Takezawa.
Takeda-san, please stay on the stage, and we heard from 13 speakers. And lastly, we'd like to have all the speakers back on the stage again. We still have some minutes, about 5 minutes. And I'd like to show the faces of all the speakers to the audience. Right, so those are the speakers, and all of them are already working on local 5G, and we already see so many of the use cases. And as Kyosura-san explained, there are many devices already ready, so we are in the station where local 5Gs can be actually used. some of the people in the audience may still be suspicious about the local FG. Maybe the speakers are only talking about good parts. To eliminate such a doubt, I like to hear a candid voice about current status of the outlook of the local 5G. Mashiyama-san from NTT East, maybe you can share the candid view of yours. Yes, my comment. As mentioned in presentations, the technological or regulatory challenges are already clearly identified. In the time of Wi-Fi, people did not really know what Wi-Fi can be used, and we didn't have device. But then, with the free Wi-Fi or the new device coming up, with the use cases becoming a present, the usage of the Wi-Fi exploded. And with regards to the local 5G, already use cases are there. And once the challenges become clear, Japanese engineers are good at coming up with solutions. So I'm confident that we are now at a turning point where the concrete usage is to be materialized. From the user side, we like to also hear a candidate view. Watanabe-san of Kyushu Electric, would you share your honest feeling or impression about using the local 5G? I'm Watanabe from Kyushu Electric. As I presented, in our department, we are not involved in device. We are involved in the network provision. In some years ago, under the demonstration project of the Ministry of Internal Affairs Communication, there are usage of robots and drones or AI detection were tested under the project. So going forward, working with the power generation department of our company, we like to proceed with those use cases. I'd like to hear from a Nawatame-san from Nokia. You explained that currently the 4Gs are in actual use, but there are potential for 5G. Nokia has many global perspective. What do you think is the actual outlook? And what do you think is the future development in Japanese market? Yes, as I mentioned earlier, globally 5G implementation is moving forward. For example, in China, there is a plant with the full automation and full wireless arrangement. In Japan, we are facing the shortage of the labor. And how are we to secure our competitiveness? Of course, AI is a one theme. In order to fully utilize AI, we need to have everything turned or converted to data which is fed into AI. Considering that, the local 5G will be an essential infrastructure to enable the full potential of AI to be unlocked. So, in an all-Japan manner, working with users, we like to move forward. Thank you very much for encouraging words. It's exactly time to end this session, and I'd like to hand microphone back to the MC. Thank you very much, Nakamura-san, and I also like to express my appreciation to all the speakers. Please give a round of applause to the speakers and Nakamura-san, the moderator. Thank you very much. So this is the end of this session too, and thank you very much once again to all the speakers and everybody who made this session possible.